Hello, all. Hope you're having a good day. I'm Aditya Philip, and I'm here with my presentation on the topic A Kickstarter TensorFlow Lite, TF Lite. Okay, moving on to the content. We'll be sweeping through the introduction, then a brief history on how this technology was evolved, then some of the key significances and why should we go for TensorFlow Lite, and some of the use cases for that for what we are using this tech. Then behind the scene, in the sense, the technical side and the next one is the stepwise procedure on how to implement a TensorFlow Lite model. Then some of the platforms supporting TensorFlow Lite. Then a small installation guide for a few devices. Then a particular case study wherein this tech was used in practical case. Then some of the companies who are currently using this tech and some of the limitations of TensorFlow Lite, then some of the learning resources, conclusion, and references. Moving on. At first, to get a better picture, let's consider an example. Let Mr. Bob be an electronics engineer and he's working on an autonomous drone. We all know, like for serving this purpose, he would have to embed a machine learning model, right? But he's facing a small issue at that part. Like we all know machine learning models are huge and bulky. And in order to implement this huge machine learning model onto a small drone, it's a bit difficult. It's practically impossible in sense. So when he looked, he had two options in front of him. Either he can go for a cloud service, or he can, like what I've said, he can embed it into the system itself, on the chip itself. So the issues he faced in both these cases are like coming to cloud. The main issues he was to face was latency, cost, and privacy issues. Latency, in the sense, we don't know what latency is, right? It's the delay for a system to respond to a stimulus. And this latency is mainly due to network issues, network latency. In the sense, if in case of cloud, we are completely relying on a on a centralized server for storage and computation, and like there can be a delay due to network issues in communicating in like channelizing the communication of the output. That's what's coming to latency. And the next one is cost. Of course, as I've already mentioned, this machine learning model can be huge and bulky. So for serving the purpose of storage and computation, it's really costly, and it can round up to a figure of $600 per year for bare minimum for a medium like model. The next one is, of course, privacy issues. As this data is stored in a centralized server, there can be an issue, there can be a possibility of breaching, or there can be a chance of interference while communication with the server and the recipient. Yeah, that's the issues when coming to cloud. And if he plan to implement it on the system on the chip itself, then the issues he's going to face are the limited computational power, limited storage, and battery consumption. Limited computational power in the sense, like a small or a small microcontroller is not capable to like run or compute a bulky or a big machine learning model. Like most of the microcontrollers are of the range of 8 to 16 byte, and it's not at all compatible for that purpose. And next one is, of course, the storage. Like you know, this microcontrollers in embedded systems are limited in their storage capacity. So it's not at all possible to store a machine learning model in a small microcontroller memory. Uh, this machine learning model can range up to 100 tens and hundreds to of megabytes to gigabytes of storage requirement. So it's not at all possible in this case. And also, coming to battery consumption for a machine learning model, there would be high power consumption power requirement, and it can't be like it can be catered by a small microcontroller. Yeah, so now let's get used to some basic technologies. Yeah, what is embedded system? That's the first one. We all know what an embedded system is, right? It's a combination of hardware and software, and it's a tightly integrated system to execute specific functions, which with a special focus on reliability, efficiency, and performance. And some of the key characteristics of embedded systems are specialized functionality, as I've already mentioned, the specific function, uh, low power consumption, and real-time operation. Yeah. Next, moving to the machine. What is machine learning? Machine learning is a subset of artificial intelligence and that focus on development of algorithms and statistical models that enable computer systems to improve their performance on specific tasks through learning from data and experience. Machine learning is widely used in various applications including speech, image recognition, natural language processing, etc. Next one is TinyML. TinyML, in short, is tiny machine learning. As I've already mentioned, machine learning a model as such is huge and big, and this is the stripped down version. TinyML is the stripped down version of machine learning, and yeah, here we can see machine. It's compatible with resource constrained edge devices with low power consumption, memory, and processing capabilities. This like some of the applications are IoT devices, wearables, smartphones, etc. Moving on, next one is what is TensorFlow Lite. TensorFlow Lite is an open source TinyML framework developed by Google, and it's specially designed to run machine learning models efficiently on resource constrained systems. So TensorFlow Lite is a production-ready cross-platform framework, which is optimized version of TensorFlow framework. And of course, it's a life-saving tool for developers working on edge computing and dynamic projects, allowing them to bring the power of machine learning to a wide range of small and resource-constrained devices. Moving on to the history, the term machine learning and AI was introduced by the mid-20th century, and that time it was not that developed. It was like kind of in the primitive stage. And by the year of 2006 to 2011, with the advancement and access in data, deep learning took root, and uh, that helped in advancing this tech and came up with major breakthroughs like computer vision, speech recognition, and natural language processing, etc. In 2015, Google introduced TensorFlow, the open source machine learning framework. And in 2017, Google officially introduced the TensorFlow Lite. And TensorFlow Lite was created to address the need for running machine learning models on mobile devices, enabling device AI. Like at that time, they specifically developed TensorFlow Lite for mobile devices, not for embedded mobile. Yeah. Now, in 2018, TensorFlow Lite 1.0 release was released, and it was a significant milestone. This version of TensorFlow Lite offered a lightweight, mobile-friendly version of TensorFlow with support for various hardware and operating systems. 2019, model optimization and quantization was introduced into TensorFlow Lite, which even enhanced the platform. In 2020, TensorFlow Lite for microcontrollers was introduced, and in 2021, the TensorFlow Lite 2.0 release was released. This version brought numerous updates and improvements in terms of performance, flexibility, easy to use, etc. Yeah, and present and future, like as TensorFlow, as I've already mentioned, TensorFlow is an open source platform, and it's having a big community of contributors, and so it's keeping on developing and developing each day. Moving on to the key significances of TensorFlow Lite. As I've already mentioned, first one is compatibility. It is compatible with variety of platforms, operating systems, and hardware accelerators. Like as a simple example, we can use that in an Arduino development platform and also even in a Raspberry Pi. That's what's meant by cross-platform or various platforms. Next one is real-world use cases. We can use this TensorFlow Lite in many of the day-to-day use cases like speech recognition, image recognition, predictive maintenance in the industrial IoT. By the way, predictive maintenance in the sense that's kind of like in most of the modern industries, this maintenance is more this the machinery and all are like monitored with a network of sensors, and also with the help of TensorFlow Lite, they were able to even enhance the technology. Yeah, moving on. Next one is the resource efficiency. Like it can, as I've already mentioned, it can be embedded into a system with no computational power, memory, and energy resources. And next one is, of course, the community support, as I've already said in the previous slide. It is having a great network of developers and contributors, and that helps in developing this platform and also sharing the knowledge, collaborating, etc. Moving on. Why should we go for TensorFlow Lite? And this is the exact answer for Mr. Bob. First one is, of course, in low latency. Since the model runs on edge, the data doesn't have to be sent to a server to run inference. This reduces the latency of output. The first disadvantage in case of cloud and the cloud was like, as I've already mentioned, the cloud was latency. Uh, the delay in deriving the output of an inference, and it is catered in this case of TensorFlow Lite. The next one is the low power consumption. As the big machine learning model is stripped down to a smaller one, we can now run it in small microcontroller with small power requirements, so reducing the power consumption issue. And yeah, of course, the low bandwidth, like as there is no or the as the reliance on the cloud is reduced, there is no need for like huge communication with external servers, and so that even so it can even operate in areas with low bandwidth. And of course, next one is privacy issues are also catered, like as the data and all those stuff is stored in the system, it's on the device itself. The chances for breaching into is like reduced. Moving on. These are some of the use cases of TensorFlow, like image recognition in mobile apps. The perfect example is this, like Google Lens. Like in case of Google Lens, we are thinking like it's going to the server or it's processing in the cloud, right? But actually, Google Lens is the inferences or the computation is done. In case of Google Lens, the inference is done on the device and on your mobile device itself. It's using this TensorFlow Lite. And next one is natural language processing. And the perfect example for that is Google Translate. And next one is gesture recognition in wearables. Like we all know, many of the fitness trackers, smart watches, and even augmented reality devices are using gesture recognition, right? And that was also enhanced with the help of TensorFlow Lite. And next one is predictive maintenance in industrial IoT. I've already mentioned what predictive maintenance is, right? Yeah, that's the one. And next is custom machine learning models for microcontrollers. Like different microcontrollers are having different requirement, and this TensorFlow Lite is not. I'm not saying it's accurate or it's compatible 10%, but it has almost covered a great spectrum, and it's keeping on developing. Yeah. You know, behind the scene, what's the tech behind that. So TensorFlow Lite is actually written on C++, and it has been tested extensively with many processors based on ARM Cortex-M series architecture. And later it was ported to ESP32, Arduino, etc. And it is open source. Yeah, this is what's actually happening behind the scene, like actually happening in case of um, creating a TensorFlow Lite model. First one is to design and train a TensorFlow or a machine learning model. We can't do that directly in TensorFlow Lite. We'll have to do it on a on a machine learning platform or framework like TensorFlow or PyTorch or any Keras or any other libraries. And after that, this model has to be there. From this part onwards, TensorFlow Lite takes place, and next is the model optimization. The model optimization includes quantization, that is reducing the model bit in terms of storage, and pruning. Pruning is the removal of less significant parameters. And thus, these quantization steps reduce the model size and computational complexity. Then this optimized model is converted to flat buffer format. Actually, flat buffer is is a buffer a storage buffer format developed by Google for serving this purpose of with low storage and high computational power. And next one is deployment. Next step is deploying this converted format, this converted model into the device. The converted and optimized model is developed, deployed to selected edge devices. This involves transferring the model file and associated files. And next is kernel optimization. This optimization leverages hardware-specific accelerators, ensuring efficient execution of model computations. And after that, and next one is like platform abstraction layer. This it consists of a layer like which helps in running this code in various platforms. And now take a let's go through a small example or a demo on how to execute TinyML, sorry, a TensorFlow Lite model. So for this purpose, we are using a sample or a built-in example sketch for speech recognition in Arduino. We are using the Arduino ID. And yeah, the first step is, as we all know, install the Arduino IDE. And after that, we have to set up the TensorFlow Lite for microcontroller, and we have to embed that TensorFlow Lite library. For that, in Arduino IDE, go to Sketches, include library, and go to the Manage Libraries. In Library Manager, search for TensorFlow Lite, and then install the TensorFlow Lite from there, library from there. After that, let's load the sketch. As I've already mentioned, we are using a pre-built example sketch. We are not going to build some as a model from scratch. The Arduino IDE, go to File, and from there Examples, and then in the example, so go for TensorFlow Lite, and from there microspeech, open microspeech, and after that connect the Arduino Uno to a computer using the USB cable. Next, configure the Arduino IDE for Arduino Uno. In the Arduino IDE, go for Tools, Board, and select Arduino Uno. Set up the correct board under Tools, then Board. Next, upload the example sketch onto the Arduino board. Click on the right arrow upload button in Arduino IDE to compile and upload the microspeech example in the Arduino. Now, we can see the output in the serial monitor. Moving on, these are some of the platforms supporting TensorFlow Lite, Arduino Nano. These are only some of the platforms. I have not mentioned all the platforms. Adafruit TensorFlow Lite microcontroller kit, STM32, then ESP32, DevKit, ESP-I, VO Terminal, Spark Phonics, Sony, SpareSense, Raspberry Pi, etc. This is a small installation guide. Uh, as I've mentioned in the index part, I haven't included all the installation, all the like installation for all the devices. It can vary depending on the platform or the microcontroller. I've just mentioned two. First one is its devices. For its devices like Raspberry Pi, running on Python, you can run this code, this command, pip install dflight runtime. And in case of using Arduino IDE, you can include this header file to include the library, include Arduino TensorFlow Lite.h. Yeah, coming to the case study, Modiface is a company developing like augmented reality programs for for companies, for cosmetic companies. So here they have used TensorFlow Lite for L'Oreal brand to build an app wherein they can try on different products of this L'Oreal virtually, like kind of in the app they can like kind of a filter, like they can try on different types of makeup kits and have a user experience, live user experience. And these are some of the companies those are using TensorFlow, like Texas Instrument, Qualcomm, OpenXG, Healthcare, Kako, Intel, Coca-Cola, Silva, Carousel, Google, etc. And yeah, of course, coming to the limitations, as I've already mentioned, this platform is currently under development only, and it hasn't covered all the available microcontrollers or the uh, microprocessors available, but it's keeping on developing. And next one is uh, like I've mentioned the second point now. The first point, like it is also not capable of running all the platforms, sorry, all the operations, okay? Like all the operations that a machine learning model can or a TensorFlow can do. TensorFlow Lite is not that capable. It's only under development. Now only a limited spectrum of operations like face recognition, speech recognition, and a few, not a few, a bit more, but not. It won't cover all the available operations. And also next one is on-device training. Like we can't train this machine learning on an embedded system or a microcontroller chip. We have to train that on a TensorFlow or Keras or other platforms, and then we have to like transfer it to TensorFlow Lite. Yeah, these are some of the resources where we can learn uh, TensorFlow Lite. YouTube, online, there are many online courses that can refer to books, then TensorFlow Lite documentation, of course, that's the official one. Yeah, coming to the conclusion, TensorFlow Lite enables the transfer of machine learning onto embedded system, significantly broadening the reach of ML. This framework has been specifically engineered to run machine learning effectively and efficiently on embedded systems with only a few kilobytes of memory. And it actually, or we can summarize like it's kind of a lifesaver for embedded software or embedded developers. And some of the fundamental contributions are addressing the unique challenges of embedded system, like hardware heterogeneity, like I've already mentioned, like different type of microcontrollers have different requirements, and most of them are being catered by this TensorFlow Lite, even though not all, but to a spectrum. Even though it is limited to a spectrum and it's keeping on developing, it can gather many of the platforms. Uh, yeah, that's all. These are the references I've used. Yeah, with that, we have come to the conclusion. Hope you all got a point on what TensorFlow Lite is and how to get started with it. Yeah, anyway, wishing you all the very best and hoping to see many embedded machine learning developers in the future. Thank you.